Alright, some of this should look familiar, some of it may have been too long for you to remember exactly how to do it, but we'll go over those. So number one, this is going back to when we were doing polynomial operations. You would need to either distribute everything here and then rewrite it and combine other terms, or write this as you're subtracting this and go from there. I'm just going to distribute and go from there. So 7a squared plus 6a minus 2 plus 4a to the third minus 7a squared minus 5. And then if we combine our like terms, the highest exponent needs to go first. Our highest exponent is this term, 4a to the third, so that will go first. Say that again. Plus 6 again. That will be part of it. The negative 7a's would, 7a squared would cancel, and then plus 6a would be next. And then if we combine our constants, negative 2 minus 5, we have negative 7. So 4a to the third plus 6a minus 7 would be our final answer. Questions on that one? Number 2, is this graph a function? Yes, it passes the vertical line test. Does not touch any place more than 1. Okay, I'm going to show you in the calculator how to do this, and then we'll go back. We'll be doing Desmos and the calculator later, which is what we're going to do today. But in the calculator, you need to go into Stat, scroll, or go into Edit, so Stat, Edit, hit Enter. Put in all of those numbers. Someone tell me what those numbers were.
2, 4, 6, 8, 10.
4, 6, 8, 10.
14, 13, 10, 10, 7.
Then you would need to go back to Stat. Scroll over to Calculate. And you're looking for linear regression, number 4. There are 2, but we want the one that looks more like our slope-intercept form, so number 4. In this case, we are just looking for the line of best fit, so we don't need to worry about storing anything, so we just go down and calculate. And it will give us our A, which is the same thing as M in this case, slope, and our y-intercept. So y equals negative 0.85 x plus 15.9. I think I said that backwards. So that would be our line of best fit. If you have any questions on that, need to see it again. We will be doing more of line of best fit stuff, kind of, but in a different way here in a bit. And I'll give back out the formula sheet so you have that as well to look at. For number 4, we needed to combine like terms. Distribute everything. We have 15x minus 20 minus 2x minus 6 plus 12x plus 24. No, it should be plus 6, right? And then combine all of your x's together. 15 minus 2 would be 13. 13 plus 12 is 25. And then minus or negative 20 plus 6 would be negative 14. Plus 24 gives us questions on that one? And then number 5, we need to graph this line. Where do you start?
-1.
And our slope is 4/3, so we're going to go up 4 to the right 3 as many times as we can, or down 4 to the left 3 as many times as we can. And make sure your line has arrows. Questions on those two? They cancel. The 7 minus 7 is 0, so we wouldn't have a square term at all. Do we have any Delta Math Khan Academy questions that we had trouble with, wanted to go over before we start our notes for today? Just a reminder, if you did not do the Khan Academies that were due on Friday, to go back and do them. I think there were 4. 2 on like quadratic characteristics and 2 on, what were we doing before that? Dividing polynomials. Today, we're going to revisit regression, but we've been talking about quadratics. Instead of linear regression or line of best fit, we're not going to be talking about quadratic regression or the curve of best fit. So these steps are only for linear, but you'll be able to see very similarly how we would do it for quadratic as well. This page may look familiar because it was the same page that we started off with linear. We're not going to do all of this. I'm just going to change a couple things. So on that front page of those notes, the process for how we do quadratic regression in the calculator and in Desmos starts off the same way. So in the calculator, you still need to put in your list 1, L2. So those steps have not changed. Go to stat, go to edit, L1, L2, put that data in. What has changed is when we go back to stat and scroll over to calculate, we're going to do number 5, the quadratic regression, instead of number 4. But then everything else will be the same. Make sure you have that written down on your own notes.
What's it say?
Quadratic regression is what that stands for. And then on the next page, we're going to change some of that as well. In Desmos, the rules are the same as well. You would still start graphing, hit the plus to find the table, put your your x's and y's into said table. However, your equation for Desmos is now different. Your quadratic standard equation, remember that our linear regression looked similar to the equation of a line, y equals mx plus b, but it had different things. Our curve of estimate or our quadratic regression in Desmos will look like the quadratic equation, but different. It will still have y1, the tilde, the stupid one. But now in the format of the quadratic, it will be ax1 squared. So when you type that, you would just type in ax1 and then raise it to the second power. Or if you are using the keyboard, actually you probably would do that also. But basically the same thing. And then plus bx1 plus c. Already. On this quadratic test, you'll be able to use this pink sheet, and I will write out the, you won't be using Desmos, so I'll write out the different steps. But on the SOL, you won't have this, you'll have to know how to do it.
We'll have one.
You won't have like these steps, or they won't tell you how to put in linear regression or anything like that, so you have to know how to do it. On your page it looks like this. That's where we'll be starting. I believe it's at the bottom of the next page. So this is this to compare. What is the equation of a, how would we write the equation of a line? Not this line particularly, but what is our slope intercept line? I equals mx plus b. Anyone know off the top of their head the standard equation for a quadratic? Aubrey, you can also put
ax squared plus 3x plus c.
And you can also look back at that equation we just wrote for Desmos. It'll be similar, but without the ones and
Was it right?
Say that again.
The equation right?
Yeah. Some of these examples are linear, so we're not going to do those. We're just going to focus on the quadratic ones. So we're going to start off with number 2, number 3. We'll do those in the calculator, and then on the next page, do those in Desmos. So with this, it does ask if it's linear or quadratic. If you got something like this, which I don't think you would, but if you did, you would graph these points and see does it make a line or a U. So you could do that really fast, -3, 2, -2, -1, -1, -2, 1. Is this linear or quadratic? Does this make a line or a U? Quadratic, because it makes a U. I also said that we weren't doing any of the linear ones, so this answer will always be quadratic. But if we were doing both at the same time, then you would be able to figure that out. To find our equation, we are going to go back to our calculator and put these 5 points into stat. So stat edit, if you were putting the one we did from the shark bite in there, go up to the top and hit clear and scroll down, and it'll clear that out. And then put all your x values in L1 and your y values in L2. Notice that your y values kind of repeat themselves. That should happen. Your x values should not. Your x values should look like they're going to go in a line, but your y values will not do that. And then go back to stat, scroll over to calculate, and we're now looking for quadratic regression, so number 5. Everyone with me so far? Because this one is just asking for equation, we can just go down and calculate and hit enter. And it will tell you what your A, B, and C values are, and you have to put those into your equation. So A is 1, B is 2, C is -1. What would our equation be?
Y equals x squared plus 2x plus y.
Y equals x squared plus 2x. So once you know how to find it, it's nothing. Just a lot of steps. Do we have any questions about that? Let's do number 3. So plot the points, graph it. It's going to be quadratic. Without finding this equation, we know that the A value is going to be positive or negative based on how this looks. Negative. Now we just have to find what those things are. So go back into stat, go back into edit. You may need to clear out your lists or type over top of them. Put in those new numbers and start to find your quadratic regression. Put in your list, go back into stat, scroll over to calculate, do quadratic regression again. And here we again only need the equation, so we can just calculate it.
Just there.
You may have put in a minus instead of a negative for them. So our equation for this would be what?
Y equals -x squared plus 6 minus
So far, do we have any questions on how we find quadratic regression?
Still says there.
L2 and L5, or L3 and L5. It's looking for A. did this, we went up to the top, we pressed the
Are there any ways to do and find the equation by hand without calculator?
Yes, but you won't be learning that in here. That is like an algebra 2 thing.
So for the SOL, if we have a calculator, we do there. But
Yeah.
we're also provided Desmos.
Yeah. Desmos will be with every question. You'll be able to access it with every question. Or I should say, from the previous practice test that they had, Desmos was available with every question. I'm hoping that is the same thing for this. I don't know why I did that. Okay, this one makes me curious. So on anywhere where you have space, we're gonna do 7 and 8, but we'll do those in Desmos. And I'll be write these down since I don't have it. So I don't know why it didn't print them like our spreadsheet, but it's missing 7 and 8, but it has 9 and 10. So you don't need to do the graphs, we'll just find the equation. So I would say write down the table somewhere, wherever you have space. And then if you have Desmos up, you can follow along with me.
Seven and
For 7 and 8, yeah. Actually, I feel like both of those are quadratic. I think only 7 is quadratic. Am I actually quadratic? We'll see. Does anyone still need these? So if you don't have your computer or have Desmos, you're going to be doing this plus you in your calculator, just as we did before. So your steps will be a little different. So in Desmos, you're going to find the plus, and you're going to add a table, and you're going to put in the values. Let's do 7 first. So if you're on your computer, you can type these in, or you can use the keyboard. So 0, 1, 1, negative 4. Once Desmos gets the pattern of the numbers of x, you can hit enter, and it will complete your x's for you. Negative 4, negative 5, negative 2, and 1. Okay. This one might be cleaner. It's not, but it looks weird. Let's see. Help a little bit. So then we're going to put in our quadratic equation, but with all of the weird ones and squiggly lines. So you can type in or use your keyboard Y1. If you're typing, the tilde, the squiggly line is above tab. Yeah. Or in your keyboard, if you go into ABC, this one right here. And you'll be switching back and forth between these two tabs unless you're typing AX1. And this needs to be squared. So I just hit AX1 and then hit the square button and it automatically did that. Plus BX1. Again, I just hit B, then X, then 1, and then plus C. And it's going to give you your A, B, and C value just as before. And we would write the equation y equals 2x squared minus 7x plus 1.
I see the
What's kind of nice about this is that the closer this is to 1, or if it's 1, the better this curve of best fit fits these points.
How do you get a one? Like underneath?
This part,
Yeah.
you just type in y and then hit 1, and it'll automatically do that. If you hit y and then 1, it will make it that. Other questions on this? If you're using Desmos for the second one, you could go back up to the table you have and just change out the numbers. Or you could delete this and add another table. But when you add another table, it changes this to x2, y2. So if you add another table, when you put in your equations, this would now be 2's instead of 1's, unless you keep the same table. So I'm going to let that be a thing. I'm going to use the same one so I don't have to change this. Because what's nice about this is I don't have to retype this since I already have it there. I just have to change my table and it'll change it for me. So I'm going to put in these values. -8, -3, -6, and 5. -4 and 9. And then -2 and 9. and 0. So because I already had my quadratic regression in there, I didn't have to change anything. It did it for me. It found the curve of best fit that fits these points perfectly. And our equation for that one would be negative 0.5 x squared minus 3x plus 5. Do we have any questions on how we put this in Desmos? We are going to do number 10 on this page, both in the calculator and in Desmos, and then we're going to switch gears and do more SOL TestNav going through that. With these word problems, imagine what is happening if you can imagine it having a curve. It's going to be a quadratic regression. So if a coin is thrown off the top of the circular, even if you just kind of like toss it like this, it would kind of go down at a curve. And really, they're throwing it up and then down, so it's still going to make that curving action. So it's still going to be a quadratic. Let's do calculator first. If you are doing Desmos first, that's fine. So we're going to put all of these values into our calculator. To go back into stat, go back into edit. If you have numbers in there, clear them out, don't delete. And fill in your table. Give me 1 second. Right now you don't find anything in all one. So we'll try with this one and it should work. Once you have your data in, data status, whatever, go back into stat, scroll over to calculate, number 5. Here we do need other things. So I'm just going to store this. And I'm going to hit alpha trace and store it in one of these. So scroll down to store regression equation is what that stands for. Hit alpha, hit trace, and pick one of those to store it in, doesn't matter which one. And then calculate it. So our equation would be negative 16x squared plus 78 plus 305. Do you have any questions on how we got that part? To do the second part, the height of a point after 7 seconds. I'm going to go back to my main screen, the second mode. Because we stored that equation in our function, I want to change my x value to be 7. So I'm going to put 7, and then this STO, and then x. So 7, this STO with the arrow, and then x, and hit enter. So that we've now stored 7 as our value of x. And then I'm going to go back and grab that equation, so alpha trace. Wherever you put yours, grab it, or hit enter at that number, and then hit enter again. Because then it will put your x value in for that equation and solve it. So when you get to your stat calculate, you're going to go to this part and hit alpha trace. And then hit enter for one of those. So our answer to that question is 67, height is in feet, so 67 feet. So it's getting closer to the ground, but not there yet. Yes,
Do you like the last 2 steps?
you hearing about this part?
Yeah.
Okay. So after you found your equation and you stored it, you hit 7 STOX, enter. That stores it for x. And then go back and grab wherever you stored your equation from. So alpha trace, wherever you stored it, hit enter, and then enter one more time. Now on the test, when you guys take that, you will need to show me that how you would have solved this algebraically, but you don't have to actually solve it algebraically. This would be y equals negative 16 times 7 squared plus 78 times 7 plus 3 over 5. Now you could actually solve it by hand, but you don't need to. Okay. So the way we did this, if you store this for x, for 7 for x, and then grab your equation, it would put this x value in for the equation you have and solve it for you. Yeah, so on second mode. Are there questions on this before we do this in Desmos? So I'm going to go back and I'm going to do the same thing, put in the numbers so that it has the equation. And I forgot one. I put these in backwards, but the order doesn't really matter. Okay. So I just used the same table. That way I didn't have to retype my equation. It gave me the same numbers. when you type in this, because these numbers are like in the 300s, you won't be able to see it unless you hit this plus. And then to find the answer at 7, we're going to retype this into an equation. So y equals negative 16x squared plus 78x plus 305. And you're going to go into your gear wheel and make this a table. We need our x value to be 7, so in this table, you're going to put in 7. And it will give you that answer of 67. It'll also plot that point wherever that is.
How do you get the 7 on that?
On the calculator.
You put it x as 7.
Yeah, so 7, store as x, hit enter, and then alpha trace wherever you store your equation. Now, if you didn't store it, then this won't work. So you have to make sure you store your regression equation on that stat calculate page. Yeah. So whatever numbers they give you, type in that equation. Go to the gear wheel. Hit table. And then in your x value, put 7, and it'll give you that answer. Do we have any other Desmos or calculator questions? Need me to do either of those back in Desmos or the calculator again? Anything like that? If we can get through the SOL, the TestNav, then you'll have time to practice. If not, I don't know if you'll have time to practice next class or not. At the end of last class, I gave you all a packet that looked like this. Take that back out. We're going to continue going over those problems. Yeah, the SOL TestNav practice. Anyone need another one of those? I believe we got through number 4. I don't remember us doing more than that. Alright, number 4. This is one where you could put this into Desmos. But if you put it into Desmos, not number 4, for number 5. If you put it into Desmos as is, it won't do anything for you. But if you change the variables, now I have different variables because you can't use the same variables for different things. So I have regression and line of best fit stuff that needs like an ABC value, then I can't use a whatever value. You could type in AB and this will work just fine for you. So whenever you type in those variables, I think the only ones you cannot use is X, Y, E, because that's the number. When you put in those variables, whatever variables you want, it'll ask you to add a slider for said variables or all, if you want to add a slider for all. So you can do that. And then it will give you some number. You want to change both of the sliders so that they're not 1 or 2, because those are really close. Change it to something else completely. You can change it to 7, you can put a negative, it doesn't really matter. I'm sorry. Don't do negatives for square roots, it'll be undefined. But whatever you change this to, then you can put in all of your answer choices with the same variable. So if I'm using I as X, then every time I see an I need to put in, every time I see an X, I need to put in I. And same thing for L and Y, or whatever variable you use. And we're looking for which one of these matches this 5.596, and there's only one. So your answer to that one would be B. Just imagine those said X and Y. Now, if you didn't remember that, you would need to do this by hand, actually simplify everything out, how we simplify radicals. Do we have questions on 5? So if you get something like this on the SOL and you immediately put this in, but nothing happens, you have to remember to change the variables, or you have to actually do that one by hand. Number 6, because these are all just numbers without variables, you can put each of those into Desmos and see which one matches. Be careful though, because often they do this. Whatever this is, they'll put 2 in here that match. So you have to figure out which one is the actual answer. Whichever one cannot be simplified is your answer. The cube root of 16, can we simplify that further? Yeah. So then that would not be your answer, and your answer would be 12 times the cube root of 2. So C. So be careful with problems like that. Do we have questions on 6? On 7, for 7, you could put in each of those into the cube root of X and see which one gives you the answer you're looking for. So it wants you to get 5 times the cube root of 7. So if we put that in, one of these things needs to match that decimal, 9.564. So we could put in the cube root of 35, that's not it. The cube root of 245, that's not it. Cube root of 875 does work, so that would be your answer. Questions on 7? Eight is something you would need to just know how to do and multiply it together. Remember, if you get something like 8, you're multiplying the outsides and then the insides. So on the outside, 4 times 2 would give us what? So that would be the number on the outside, and then 2 times 3 would give us, and that would be the number on the inside. We have 8 times the square root of 6. This is a drag and drop, so you would drag the numbers to where they would. Questions on that? For 9, that is also something you would need to know. Desmos can't really help you answer that. If Michelle correctly solved a linear equation and the last line of her work was 1 = 2, which statement best describes the solution?
The equation has no solution.
has no solution. If this was, the equation has infinitely many solutions, what would that look like? 1 equals 1 or 2 equals 2, either of those. If the solution is 1 or the solution is 2, it would be x equals 1 or x equals 2. Or the solutions are both 1 and 2, it would have to be x equals 1 and x equals 2. For number 10, this is something you can do in Desmos. You can solve this any of the ways that we talked about, factoring, putting it in Desmos would be the easiest. So if we put this one in Desmos, I think so this is really skinny, but that doesn't really matter. When you graph it, look at where does this cross your x-axis, and you should be able to match. If you don't know what the fractions are, because Desmos likes decimals a lot, you could start putting in the fractions, like if I put in -3/2, I could use this button right here to change it from fraction to decimal to see is that the same thing as what I was given. And that would tell you that C is your answer. Questions on 10? For 11, things that are equations or inequalities, those can be put into Desmos as well. If you put it in and nothing shows, you'd have to put each side of it in separately. But if I put this one in, this will show me that it's going to be a dashed line, which makes sense because it was just less than. You can look at your x-intercept to see what the solution would be, -9. But your answer here would be everything above -9. So you would write in x is greater than -9.
What was the 10?
Number 10 was
Oh, I see.
C, because if I put this in the Desmos and I look at these two, those match. Do you have any questions on 9? I'm sorry, on 11. I went backwards. 12 is very similar. You can put that in all the way. This is a drag and drop, so you would need to know which inequality line you need. This would start at -4, so at -4 you would drag whichever line up to that point. Would this be an open or a closed circle?
Open.
Open. To be the open circle that goes to the left. So you would drag this one up to -4, and it would graph it for you. These could be solved, but you also have Desmos to check yourself or to put in. Questions on 12. For 13, This is one where you would need to be able to set up the inequality, and then once you set up that inequality, you could put it into Desmos and find which one matches, or look at the graphs given and find which one matches. So if he earns $7.50 per hour that he works during the day, and $12.50 per hour when he works at night, he was to earn at least $300 per week. This would have two different variables. You can say X is the number of hours worked during the day, Y is the number of hours worked at night. We have 750X or 7.5X plus 12.5Y. At least, how would we write that inequality symbol? Greater than or equal to? Let me move this down. So we would need to know that inequality before moving on. Now, we could look at these, all of these are solid lines, so that wouldn't change anything. This is greater than 300, so it would have to be C or D. We would just need to figure out which one. So you could put this in Desmos and figure that out. When you put it in, you may also need to zoom out because it's at 300. So if I look at my X and my Y intercept, I'm at 24 and 40. So the one that looks similar to that would be C. So some of these you can't just put in Desmos if you don't have what you're supposed to put in Desmos. So you do need to be able to find that information so that Desmos can help you with that. Do we have any questions on 13? For 14, you could, the lines are already drawn for you, and you could figure out which one is which and then find the correct shading. You could also use Desmos. So without changing anything, I would put both of these into Desmos and see what they look like, see where they intersect. Or where their solution points intersect. This would be just a select which number. So if you look on the graph, there are numbers that go with these regions, 1, 2, 3, 4. Of the regions, which one would be the shaded area? Does it overlap? I'm sorry, 2. 2 would be correct. I said the wrong thing. Do we have questions on that? Moving on to 15. Now 15, they're a graph for you, Tom. So this is graph for you, and it basically has the equations. You just have to figure out which symbol it is. Desmos could help you, but then it would be like a guess and check thing. So I'll show you that here in a second. This one may just be easier to look at it by hand and do it that way. So this first one has a y-intercept of 2, so this is going to be the line that's similar to that. It is solid, so it has to be greater than or equal to or less than or equal to. And it's greater than or equal to because it's shaded above. then that means the other one is this line. This is a dotted line, so it has to be less than or greater than, not the equal to's. Now this one is weird because of the way it's written, so if you wanted to rewrite it, it would be y is less than 2x plus 5. But because this is flipped, y has to be less than, so this would be, our function is greater than 1. So if it's flipped, you also have to flip it. Whatever direction the symbol is pointing towards the y needs to be the same way. So if it's pointing towards the y, it needs to also point towards the y when you put it in.
Less than that.
Because that's the inequality itself is flipped. Now, if you wanted to put this in Desmos, you'd have to do this one of 2x. One, you could put in each one and see which one matches. So I did this separately. I'm just looking at the first inequality, and I put in each of the 4 symbols. And I would need something that has this line, but is shaded above it. So it can't be less than, and it can't be less than or equal to. But it could be one of these two, except it can't be the dash line. So you could do that. I think I have something else open. That's why. There we go. I was like, what else is open? So that would tell me it has to be greater than. And then I can do the same thing for, or greater than or equal to, I should say. And then I could do the same thing for the second, put each of those in, and see which one matches. It may help if you saw just one at a time. So this one doesn't look like what we have, so it's not that. This one also doesn't look like that, so it's not a less than. It is a dashed line, and it is shaded in that direction, so it would be that greater than. And that would also tell you you picked the right thing. Do we have any questions on 15? I'm going to go through the next few, but these will be the things that we're talking about in the next coming weeks. Linear transformations, 19, 20, 21, and 22 are some things we have already talked about. And so is 23. Then inverse and direct variation is something we'll be talking about next class. That's been fun. So it's 16, and again, this will make more sense when we go over it. But for now, anytime it's talking about comparing the graphs, we're comparing these two graphs. So you could graph them and actually compare them visually, or you could look at them just looking at the equations. For the graph of g of x is shifted, that's going to be up or down. You're looking at your y-intercepts and comparing them. What's the y-intercept of this original? The first one?
1.
0. And the y-intercept of the second one? -1. So if you're comparing from 0 to -1, did this move up or down? Down. So that would be a drop-down menu that you would choose down out of. In the second one, you're looking at This is talking about slope when it's talking about steeper or less steep. What is the slope of the first one? 1. And the slope of the second one? 6. And really you're looking at which one is greater. If this one is greater, then it's steeper. If this one was greater, then this would be less steep. So the 6 is greater, so that would be steeper than the first. And I'm going to show you how you do that in Desmos, or really look at it in Desmos. So if I put both lines in, I would need to know what the shifted up is looking for. I would need to know that that's looking for my y values, or my y-intercepts. And so if we're looking at our y-intercepts, we could look at them like this, compare them. One is less than the other. The original has a higher y-intercept, so I could say that this y-intercept shifted down and moved down. And if I'm looking at the steepness, I have to know I'm looking at slope. Visually, you could imagine you are skiing or sledding or whatever down these lines. Which one would you get down faster? The blue one. You would basically almost fall off that one. But yes, you would get down the blue one faster, so that one would be steeper. We're going to do these last two and then we'll stop for today. For number 17, this is another linear transformation one, where we're comparing the original f of x equals x to this graph of g of x. So if we're comparing the slopes, what is the slope of this graph?
Wait, 1/2.
It is 1/2, yes. So is this greater than the slope of the first or less?
Greater.
Should be less because the slope of this one is 1.
So we get 1/2.
But our answer choices, it wouldn't be twice. It wouldn't be less than or more than because that's reserved for shifts. But we could say it's 1/2 of the slope. So anytime we have less than or more than, that's talking about did it shift up, did it shift down. So those answers would not go for slope. Anytime you are multiplying or dividing, that's going to talk about slope. So if we're comparing this one to one, did we multiply by 2 or did we divide it by 2? From 1 to 1/2. Divided by 2, so it'd be 1/2 of this original slope. For the second one, looking at your y-intercepts, the y-intercept of g of x is what? 2. What is the y-intercept of the first one?
0.
0.
2 more than.
So it's 2 more than, yep. So as long as you don't switch those are, for the most part, easy. You just have to remember shifting or moving is y-intercept only. And then again, you could have put those both into Desmos and compared them like that as well. For number 18, last one we're doing today. If this says shifted up 2 and 3 times SC, what would my slope of this new graph be? What would my y-intercept of this new graph be?
It's already at the original line is at 0, so if you shift up 2 units, our y-intercept would be 2. And if it's 3 times SC, our slope would be 3.
So our b value would be 2, our slope would now be 3. We're going to start at 2 and then go up 3. We just need to plot 2 points, so you don't have to draw the entire line. Any 2 points would work. Y-intercept is always a good first start. And then you can go up 3 to the right one, or down 3 to the left one, or if you want to be the person that keeps doing the slope until you get the point way over here, that's fine too. You just need 2 points. As long as you have 2 points that fit this, that would work. Next class, we may not have time to continue through this. So if we don't, hold on 1 second. If we don't, then we'll continue that next week. However, your SOL A6, A6C, and A7A through D, or you will be going on that next class. I'll be looking at questions. For yours, I think it was on that card. Oh. It's TBD. Let me look and see. Alright, you guys can grab your phones and put your calculators back.